Okay, so this will be our first introduction to nonlinear patterns, and the first one we're going to look at is something called a quadratic pattern. And you can identify a quadratic pattern because they have a second common difference. So like in the first patterns we saw, linear patterns, we saw that there was one common difference, and that was it. So like it might be 2, 4, 6, 8, 10. It went up by 2 every time, and that was the first difference. So let's have a look what we mean by second difference. So let's have a look. This guy goes up by 5, so I'll say plus 5. This guy goes up by 14, plus 14. This guy goes up by 23, 23. And I'm not sure what this is yet. Alright, could probably work it out if I took a minute to think about it. But let's have a look. What's the difference between this guy and this guy? That's plus 9. That's going to be plus 9. And so this, it stands to reason that this will be plus 9 as well. So plus 9. And that you get plus 32. Alright, add 32 to that, you get 59, 79. Alright, plus 9 gives me 41, plus 41. Add 41 to that, I get 120. Alright, plus 9 gives me plus 50, which gives me 170. Alright, I hope that's clear, just having a look on the screen. I think it's pretty clear. Alright, so you can see the start term is 15, and the second difference is plus 9. Alright, so the first difference is actually different every time. It goes up by 5, up by 14, up by 23, but the first difference goes up by the same amount every time. This is called the second difference. And a pattern is considered quadratic if it has a second difference. That's important. That's the definition of a quadratic equation. How do I know it's a quadratic equation? It has a common second difference. Alright, a linear equation has a common first difference here. So in this case, first difference is going to be plus 4, then it becomes plus 1, then it becomes minus 2. Alright, so let's have a look. What's happening here? This has been reduced by 3, this has been reduced by 3, reduced by 3, right, reduced by 3, reduced by 3. So the second difference can be negative as well. So down by 3 is going to give me minus 5, down by 3 is going to give me minus 8, down by 3 is going to give me minus 11. So 4 minus 5 gives me minus 1, minus 1 minus 8 gives me minus 9, and minus 9 minus 11 gives me minus 20. Start term is 1, second difference is minus 3. Okay, so that's our first introduction to quadratic patterns. Okay, so the next thing we're going to look at is the general sequence of a quadratic, or the general term, sorry, of a general sequence. What is it? How do we get it? And how is it even a thing? So the first thing we'll discuss is, so the first thing to realize is that it's very important to know that all quadratic sequences follow this particular pattern here. And I want you to pay particular attention to the letter A, which is always going to be the number in front of the n squared. Okay, so A, the coefficient of n squared, is important for this first part. And before we learn to actually find the general term for ourselves, it's important that we learn how it is actually a thing and where does it come from. So let's look at this example. Why does the sequence 4, 13, 28, and 49 form the general term 3n squared plus 1? Okay, so you can think of this as term 1, term 2, term 3, and term 4. Alright, now I've done this table out. This is the exact same table in your book. I can't remember what page it's on, but it's just a couple of pages after where we've left off. So to find t of n, in this case n, term is always given the letter n. It's 3 multiplied by 1 to be squared plus 1. So 1 squared is 1, multiplied by 3 is 3, plus 1 is 4. There it is there. Term 2, 3 multiplied by 2 to be squared plus 1. 2 squared is 4, 4 times 3 is 12, plus 1 is 13. There's term 2 there. Then 3 times 3 to be squared plus 1 is going to be 9, multiplied by 3, which is 27, plus 1, which is 28. There you have it there. And 3 times 4 to be squared plus 1, 4 squared is 16. 16 times 3 is 48, plus 1 is 49. Alright, so let's have a look. First difference. Well, obviously there's no first difference between the first term and itself. So the difference between 13 and 4 is 9. Alright, and the difference between 13 and 28 is 15. and the difference between 28 and 49 is 21. And what's the difference between these guys? So if there's nothing to go there, nothing to go here, nothing to go here, the difference between 9 and 15 is plus 6, and the difference between 15 and 21 is plus 6. We've already seen quadratic patterns, and I just dropped my marker, and I'm back. So we have a second difference of 6. Now this is very important. For all quadratic sequences, the second difference, if you know what the second difference is, in this case, the second difference is equal to plus 6. Then a, which is this value here, okay, the number in front of n squared, is always equal to the second difference divided by 2. So in this case, a is equal to 6 divided by 2, which is equal to 3, which is what we have. 3 in front of that. That happens for all quadratic sequences. And if you don't understand this, rewind, watch it again. Make sure you understand where a comes from. It's always the second difference divided by 2. Because this, we're going to use this fact to actually find general terms for ourselves. Okay, so this example is on page 93 of the book. Stay on the bottom, all right? And it takes a little bit of work and a bit of practice, but it's actually not too bad if you understand the last part where I was saying how we find a, all right? So to find the general term for this sequence, right, the first thing we're going to have to do is find the second difference. So to find the second difference, it's just, let's have a look at the first difference. The first difference here is going to be plus 4, then it's plus 12, then it's plus 20, all right? Then the difference between the differences, or the second difference, is going to be plus 8, and then it's going to be plus 8. So the second difference is equal to plus 8. Therefore, right, those 3 dots mean therefore, a is equal to 8 divided by 2, so our value for a is 4. All right, now this is important. We don't know what the general term is yet, but we do know it should be something n squared, so we know the number in front of the n squared, and that number is 4. So how does that become useful to us? So I'll set that up now. If we have a look at the page after that, it'll go through. Okay, so we know that all quadratics should follow this form here, where t of n is equal to a n squared plus b n plus c. That's what we know. And now we also know that Tn is going to be 4n squared plus bn plus c, because we just worked out what a was. Alright? Because remember, where did I get this from? A is always half of the second difference. So we found out that the second difference was 8. We divided it by 2. That's where my 4 came from. And that's my value for a. Alright? So it's important then, we are now going to sub this in. So what we're going to do is we're going to need to make 2 equations here. Alright? So let's find the equation for t of 1. Alright? Where n is equal to 1. That's going to be 4 times 1 to be squared. Right? Because n is 1 and I know this 4 is here. Plus b times 1 plus c. Alright? Let's see what I get. I get 1 squared, which is 1 times 4, which is 4, plus b times 1, which is b, plus c. Alright, so the first term, t of 1, is equal to that. Now I'm just going to rearrange this, alright, and I'm going to bring the 4 over the equals, and I get b plus c is equal to minus 4. Alright, let's leave him there for a second. Now, that's great that I have a, but I still haven't worked out what b or c is. Alright, so I'm going to work out what b or c is. I'm going to have to do what's called a simultaneous equation. So I'm going to have to take my t of 1, and I've gotten one equation out of it. So I'll go to t of 2, and I'll sub that in and get another equation. Now what's important here, lads, is that I could use any term. I could use t of 100 if I want. But it makes more sense to stick with low numbers so it doesn't get too messy. Alright? So that means that my formula is now going to be 4 times 2 to be squared plus b times n. Sorry, n is 2 plus c. Alright? So what do I get now? 2 squared is 4, 4 times 4 is 16. b times 2 is 2b, and then I get plus c. Again, just going to rearrange it in this form here. I'm going to bring the 16 over. I get 2b plus c is equal to minus 16. That is a 12, minus 16. Okay? So, now what? Okay, remember that b and c have to be the same, or like the b in this value is the same as the b here, it's the same as the b here. Likewise, the c is the same here, as it is here, as it is here, as it is here. So that means we can actually add these equations together. This is important because this is the basis of simultaneous equations. So watch, I'm just going to use this space here. Okay, so I have b plus c is equal to minus 4, and I have 2b plus c is equal to minus 16. Now, what I want to do is I want to find either b or c first, use that value and come back. But the thing is, I can't really cancel anything out just yet, so I'm just going to multiply the top line by minus 1. Okay, I can do this, I can multiply it or add to it or whatever I want, alright? But I'm doing it in such a way that it'll convenience me now in a second. So watch, if I multiply the top line by minus 1, I get minus b minus c is equal to 4. I'm not going to do anything to the bottom one here. 2b plus c is equal to minus 16. Okay? Now I'm going to add these guys together. And look, minus c plus c cancels. My c is gone. Now I have minus b plus 2b just gives me regular b. And 4 plus minus 16, which is just the same as 4 minus 16, is going to be minus 12. Now I have a value for b. Alright? So now that I have a value for b, I take it, I sub it back into either of these equations. So I'll just start with this one because it's the easier one to put it into. So minus 12 plus c is equal to minus 4. So c is going to equal minus 4 plus 12. c is going to equal 8. Alright, so b is equal to minus 12, c is equal to 8, and I have my a, which I worked out earlier, which is equal to 4. Final answer. So, remember, all sequences follow this pattern here. So t of n of this sequence, t of n of this sequence is going to equal 4n squared, because a is equal to 4, right? A. B of n, or b multiplied by n, we worked out that b is minus 12, so it can be minus 12 times n, plus c, which is 8. And that's my final answer there. I hope these videos were useful. Alright, I apologize how late they've been uploaded. And this video might be a little bit longer than I meant it to be, but we've covered a lot and we should be well prepared for our lesson tomorrow. Okay, thank you.